Once more, welcome to this YouTube channel, and today we're going to use Thompson's method to find harmonic conjugate. And let's look at the example below. Given that u, a function of x and y, to be equal to 2x minus 3xy squared minus x cubed is harmonic, find the harmonic conjugate v of xy using the Milne-Thompson's theorem. Alright, let us look at the solution. We have our u equals to 2x minus 3x cubed minus 3xy squared. So from the equation we have, it is 2x plus 3xy squared minus x cubed, not 2x minus, sorry. Okay, let us look at the solution. We have our u to be equal to 2x minus x cubed plus 3xy squared. The partial of u partial x to be equal to 2 minus 3x squared plus 3y squared. Okay, our partial u partial y will be equal to 6xy. Alright, then we now choose, you can call it beta or theta, maybe theta 1 function of x comma y and theta 2 a function of x comma y. Our theta 1 should be equal to the partial derivation of u with respect to x, that is partial u partial x, while our theta 2 function of x comma y should be our partial u partial y. Alright, and let's say our theta 1 as our z0, a point z0. Then when we substitute our theta 1, kindly notice that there is no I in between theta 1, a function of z and z comma 0. When you substitute z comma 0, we'll have 2 minus 3z squared to be our theta 1. Then theta 2 was supposed to be 6xy. When you substitute at point z comma 0, we'll have our z to be equal to 0. Therefore, the derivative of the function f of z is equals to our theta 1 plus our theta 2, which is 2 minus 3z squared plus 0. And because we have the derivative of f of z, we can find the integral so that we get the function of z to be equal to the integral of 2 minus 3z squared dz. Okay, so our f of z is equal to 2z minus z cubed is a constant. Now, we know that f of z is in the form of u plus iv. Let us say z is equal to x plus iy, a complex number. Then f of z is equal to 2 into z, which is x plus iy, minus x plus iy cubed. Alright, this will be 2x plus iy minus, you expand that one, that is binomial expansion, but the power is 3, the highest powers will have x cubed minus 3xy squared minus 3ix squared y minus iy cubed. Right, solving the equation and collecting like terms, will have 2x minus x cubed plus 3xy squared plus I into 2y minus 3x squared y minus y cubed. And because this is in the form of u plus iv, we'll have our u to be equal to 2x minus x cubed plus 3xy squared, and v to be equal to 2y minus 3x squared y minus y cubed. We were solving for the conjugate of harmonic conjugate of v, of u I mean, which is v, and we have already got the answer. Thank you, and please subscribe to this YouTube channel. Meet you next time for another example on calculation or proving the analyticity or harmonic conjugaticity. Thank you. Goodbye.